Hello, we're looking at problem number 3 using the exponential model. It says physics. The best temperature to brew coffee is between 195 degrees and 205 degrees. Coffee is cool enough to drink at 185 degrees. The table shows temperature readings from a sample cup of coffee. So here's a sample cup of coffee, and after 0 minutes it's 203 degrees because that's when it's best brewed. And it goes on. So after 5 minutes it's 177, 10 minutes is 153, and so on and so forth. After 30 minutes is 104. It says, how long does it take the cup of coffee to be cool enough to drink using an exponential model? So I do not, well, I do have access to the calculator that they have, but I'm going to show you a free calculator. It's called Desmos. So it's www.desmos.com. And I've already put in the values. So the way that you do that, you go to add an item and you add tables and you just click in the numbers. So I put for the first one 0 and 203, 5 177, 10 153, just the same values that we have here. So 15 137, as you can see, 15 137, and so on and so forth. Now, one thing that they took into consideration is that room temperature is 68 degrees. And they did that because we know that we're not going to go, our coffee is not going to go lower, or it's not going to continue to drop. So it's going to have that kind of asymptote at that 68 degrees. So 68 is the lowest that it's going to be able to go to. So the first thing that I did, I put in my values. Then they asked me to subtract 168, but they asked me to subtract 68 from each of the points. And so now I'm going to look at the graph. I'm going to just zoom in, or zoom out, excuse me. And those are my graphs. The blue one is the one after I subtracted 68. And the green one is the original one. So now I'm going to find a regression of the blue one. So it's going to be y2, because I'm finding it for my y2. Then I'm going to hit tilde, which is right beside the number 1. I'm going to hit shift tilde. Then I'm going to hit A times, which is the little star button, B raised to the x1. And so here's my x1. Okay? And as you can see, it fits it almost perfectly. Look at all of my dots are being hit right there. And you probably can't really see it that great, that it doesn't necessarily hit everything perfectly, but because I had to zoom in so much. But as you can see, it does a really good job of hitting it. And if I plot the residuals, you see that it's right there. So this one is a really good fit. And so my parameters, A is 135.6 and my B is 0.95551. Now in the book, when they did it, they got 134 and 0.956, which is slightly off, but not that big of a difference, let me assure you. So let's go back here, and we're going to graph it now. So we have our equation. So y equals 135.36, that's my A value, times my B value, which is 0.95, let's do 56, and then I'm going to raise it to the x power, and then I'm going to add, because I subtracted 68, I'm going to add 68 to it. And so as you can see, my line takes me right back up to this green, to the green points, which was my first set of points that I plotted. So I just added the 68, and as you can see at 68, I am kind of leveling on out because I can't go lower than that 68 value. Okay, so let's see what else it asks us to do. It says find out how long it takes coffee to cool to 185. Now, one thing about my Desmos is that it doesn't give me these decimal values. Maybe someone can figure out how to do it, but I can't figure it out. I can go in here and add a value. Oops. I'm just going to change this convert to table, and there it converts it to table. And as you can see, I can add values to it by just hitting enter. But it doesn't give me that 3 that they're asking for. So I know it's here in between this 3 and 4 somewhere. So I can zoom into my graph and I can actually click on my graph settings, and I'm going to put between 3 and 4, so I can be right there on it. And and it's already giving me the steps that I need. The only thing that I need to do now is zoom out. Sorry about that, I have to stop the phone. Let me go here to my settings again. And let me do, I know that I'm looking for, let's do between 180 and 185. Okay, there it is there. Okay, that's 4 and 180. Let's zoom. We want 185. So 185 is about right here. Okay, you see that point is 0.32. Let's see if we can get closer to 185. Just moving it up. And it looks like that's as close as I'm going to get. So it's about 3.2. So in the book they got 3.1 and we got 3.2, which is still pretty close. So it takes coffee about 3.1 to 3.2 minutes to cool to 185. Let's go on and look at guided number 3. It says use the exponential model. That's the same model that we just used. How long does it take for coffee to reach a temperature of 100 degrees? Let's go back to our graph, and I am going to zoom out, and I want to go all the way down to 100. So if this is 150, this is 100 here, and I'm going to go over to right here, and that is 104.30. Let's put that in our graph. Let's see what it is when we put in 30. And we have too much, so we'll go down one. Let's do 27. That is not enough. We'll go to 29. So let's try 31. It's getting closer. Let's try 31.2. Even closer. Let's try 32. Oh, that looks really close to me. So about 30, after 32 minutes, it looks like it's going to reach 100 degrees. So I hope that this helps. And let's go to the reasoning. I'm sorry, in problem 3, with the model of the exponential data be useful if you do not translate the data by 68 units? Explain. Well, we talked about that already. Let me try to zoom all the way back out. We know that if we didn't take into consider the 68 units, the 68 as our room temperature, then our graph would have just kind of kept going down, and that wouldn't have made any sense. So we definitely needed the fact that 68 was room temperature, that our coffee temperature was not going to continue to decrease. I hope this helps.